Alright guys, today we're going to solve quadratics by using the square root operator, or square rooting it. This one is actually kind of the quickest way to solve. So yesterday we did factoring, today we're doing square roots. It's the quickest way, but it only works if we just have an x squared and a number. That's our end goal, is what we want it to look like in order for do it. If it has an x term, we can't use square root properties. So that's what kind of stinks about square roots, is you can only use it certain times. Alright guys, so for our warm-up, okay, what are the possible values x could be for this equation? So x squared equals 9. So what could x be? Well, a lot of you guys are like, oh, x could probably be 3, because 3 squared equals 9. Okay, 3 times 3 is 9. Let's also think though, what if I did negative 3 squared? Okay, well, negative 3 squared is negative 3 times negative 3. That also would equal 9. So x could actually be 3 or negative 3. Okay? And kind of a way that we could write that is x equals a positive or negative 3. That's kind of a shortcut of writing both positive and negative 3. Another thing that we need to look at is simplifying radicals. Okay? This kind of takes us back, but remember, when we want to simplify a radical, square root of 28, I don't know what the perfect square of 28 would be, but I know that I could break it down into two terms. Well, 28 is 2 and 14. Okay? And then 14 can be broken down into 2 and 7. Okay? I cross off that 14 because I'm not using it anymore. And when we're doing square roots, we're looking for pairs. So there's our pair of 2's. So I'm going to bring 1, 2 out. And what's left inside of the square root is this 7 that doesn't have a pair. Okay? Let's simplify square root of 72. Well, 72, okay? I know 2 goes into both of those. I also know that this could be 8 and 9. Okay? You could do 2 or you could do 8 and 9. Should still get the same answer. Well, 8 is 2 and 4. Okay? And then 4 is 2 and 2. Now if I break up 9, 9 is 3 and 3. Okay, now we're looking for pairs. Okay, so I have a pair of 2's and a pair of 3's. So if I have two pairs that are coming out, we multiply those. So 2 times 3 is 6. And then I'm left with this 1, 2. So that's going to stay inside of the square root. Okay. Now if I do the last one, 50, well that's 5 and 10. And then 10 is just 5 and 2. So I have a pair of 5, so 5, and then I would leave that square root 2. Alright, if there was two things left that would be on the inside, I just would multiply the stuff on the inside. So anytime there's pairs or things left behind, we multiply them if they're going to be on the inside or outside. Okay, so our steps. So that was kind of to get us ready for this. So now our steps when we actually solve using the square root property. The first thing is we need to get x squared on one side by itself. Okay, that's the first thing you need to do. Then we're going to square root each side. Don't forget that it's going to be the positive and negative value, just like we talked about on that first slide. Okay? And if we can simplify our square root, we're going to simplify that square root. So let's take a look at some examples. Okay, so this first one, I need to make sure that the x squared is by itself. So the first thing that I'm going to do is add 3 to both sides. Okay? So I'm going to have 4x squared equals 36. Okay? Divide both sides by 4 because I need to get x squared by itself. So x squared equals 9. Now once we have that, we're going to square root both sides. Let's change colors. So I'm going to do square root both sides. So I'm going to have x equals. Now if I square root both sides, we have to remember that this could be a positive or a negative 3. Okay? Just like we talked about on that first slide. That would be my answer. Now let's look at this next one. I need to get the x squared by itself. So what's the opposite of 13? Be subtracting 13. Okay, so I have, don't forget this is a negative 2x squared equals, that would be 48. Negative 48. Divide both sides by negative 2. Okay, x squared equals a positive 24. Okay. So now I'm going to square root both sides. So x equals plus or minus square root of 24. Now we can't say that that's our final answer. We have to actually see if we can reduce this square root of 24. So let's break this down. This is 2 and 12. Okay. 12 is 4 and 3, and 4 is 3 and 3. Now I'm going to go ahead and cross these off so I don't use them again. So I have this is 2 and 2, not 3 and 3. So there's my pair of 2's. So a 2 is going to go on the outside. And then I'm left with a 2 and a 3. So we multiply those, so I have 6 left on the inside. Okay, so x equals plus or minus 2 square root 6. All right, let's look at this next one. Well, x squared is already by itself, so I square root both sides. So x equals plus or minus square root of 49. Well, that's just 7. Notice how I didn't put square root 7, I just put a 7. So if it breaks down evenly, we're just going to put it as a square root of 7. Okay. This next one, subtract 7 from both sides. Okay, so I have 4x squared equals 180. Divide both sides by 4. Got to remember to make sure we get x by itself. Some people want to square root when the 4 is still there. You got to be careful. Can't do that. So I have x squared equals 180 divided by 4. Well, that's going to be 35. Okay. Square root both sides. X equals, remember, square and square roots cancel out. That's why we square root both sides. So plus or minus square root of 35. I'm going to go ahead and just break that down. That's 5 and 7. Well, I can't break 5 and 7 down anymore. So there's no pair, so we're just going to leave that as the square root of 35. And that's our answer. All right, we got 2 more left. So let's go ahead and take a look. We'll subtract 11 from both sides. So I have 4x squared equals, that's going to be 25. Okay. Divide both sides by 4. Okay, so x squared. Now if I look at this, I can't divide 25 by 4. That's okay. Let's just leave it as a fraction. Okay, because I do notice those are both perfect squares. So when I square root both sides, x is going to equal, well, the square root of 25 is 5. The square root of 4 is 2. Okay, so my answer is going to be a plus or minus square root of, or not square root, just plus or minus 5 over 2. So it's okay with fractions. We're just going to square root the top and square root the bottom, and then just leave our plus or minus sign. All right, we're almost done. We're going to, this one, let's just divide both sides by 3. So x squared equals, well, 45 divided by 3 is the 15. Okay. So square root both sides. X equals plus or minus, well, the square root of 15. Hey, that's just 3 and 5 if I break it up. So there's not anything that I can break it up into. So we're just going to leave it as the square root of 15. All right. So the big thing to take away is remember that we have that plus or minus sign anytime we square root both sides. And always try to reduce your radical if you can. So how do you know it's possible for you to use the square root property to solve a quadratic? The only time you can use it is when you have an x squared and a c term. So when you have no b term in your equation. And remember that the b term is the x. Remember, it's ax squared plus bx plus c. Okay, we can't have that b term. And that's the only time you can really use the square root property.